Hello students, welcome back. In this class, we are studying about the transmission of pressure in liquids. In the previous class, what we have discussed was laws of liquid pressure. In that one, what we have studied is the liquid pressure in different layer of the liquid is different. Like as we go depth into the bottom of the liquid surface, then what happens? The pressure increases. Just take a glass of water, the pressure at the bottom of the glass is more than the pressure at the top of the glass. So liquid pressure is different at different level. So transmission of pressure means to transfer pressure from one point to another point. That was given by Pascal's law. And if you also know that in the previous class I have told you that Pascal is the name of the scientist after whom the unit of the pressure is also mentioned. So in this we will discuss about how the pressure is transmitted and what are this useful in for further studies. So I have already told you that when there is a pressure difference, suppose if you increase the pressure at one point of a liquid, at a certain point of a liquid, then that another point or another surface of the liquid the pressure will also increase. So if you increase the pressure at one point, simultaneously the pressure of the whole molecule of the liquid will start increasing. It might sound confusing, but let us see a few diagrams to understand this better. Okay. This is the law. You can write down the statement, that is, the pressure exerted anywhere in a confined liquid is transmitted equally, undiminished in all directions throughout the liquid. Suppose you have liquid in a bucket of water, you have a bucket filled with water, you exert pressure at one point. That pressure will be distributed among all the molecules present in that bucket, that also equally and undiminished. The pressure will not decrease, equal pressure will be distributed. That is what this law says. So, over here in this diagram, this was the demonstration of Pascal's law. What they have done is they try to demonstrate it with this kind of a device. So over here you can see first of all this dotted line over here this dotted line is the actual level of the water. Water is filled inside this flask. So now there is a piston. When we push the piston, the pressure over there increases. Pressure inside this flask will increase. So there are four different holes over here at different positions. So this is to demonstrate the Pascal law. So what is Pascal law? It is if you increase pressure at one point, the pressure of all the molecules of all the level of the liquid will simultaneously increase and it will increase equally. So now when you press this piston, what happens? Initially the level of the water was over here. If you press this, the pressure will, the level of the liquid will go down. It has reached over here, and due to the pressure is force per area. Okay, due to the pressure, the liquid will emerge out of these pipes. Okay, it will emerge out of these holes. So from here, what we can see is the amount of pressure ejected from this hole has reached the same distance. So it has emerged out of hole with the equal pressure. Okay, with the equal pressure. That means all the molecules over here also, they got pressure from this part. The pressure was applied at this point, but the pressure got increased at each and every point over here. That is why the water emerged out of the flask. So this is the demonstration of Pascal's law. The same diagram is there in the book also. You can refer to the diagram given over there. Now let us move on to second figure. Initially the figure which I have showed you was a round flask. Now this is kind of a rectangular body. Same kind of demonstration is done over here. It is a rectangular body. So there is a piston. It's quite not visible. There is a piston over here. When we press this piston, the pressure at this point is applied. Pressure is at this point. And that pressure gets distributed equally in every part of the liquid. So that same pressure is like downward, sidewise as well. So it doesn't matter where you have applied the pressure. but that pressure gets distributed, not distributed actually, that pressure is transformed or transmitted to each and every molecule over there. So that is the transmission of pressure from one point to every corner of this vessel or this rectangular body. So pressure gets transmitted. So now using this law, what can be developed, what things can be made, that we will also discuss. Now over here, this is the principle of hydraulic machine. Now I hope you have studied about or heard about hydraulic machines. Hydraulic machine is quite used to lift things, or in machineries like in cotton industry, so many industries, this hydraulic machine, hydraulic brakes, so many things are used. So this is a basic principle of how a hydraulic machine works. So statement is given over there. Principle of hydraulic machine. A small force applied on a smaller piston is transmitted to produce a large force on a bigger piston. So as Pascals law states that if a force is applied at one point of the liquid, it gets transmitted to every part of that liquid. So same law has been applied to make a hydraulic machine. So first of all, you can look over here. There is this box where the liquid is filled from this part to this part. So these two parts are attached to each other. So this area is A1. The area over here at piston B is A2. So what you can see is the pressure over here is P1. The pressure over here is P2. The force which is applied by the piston is F1. The force at this point is F2. And there is liquid over here. Now, what you can see easily is A1 is smaller. The area of this part of the piston, this part of the hydraulic machine is smaller than the area over here, that is A2. You can easily make out that A2 is greater than A1. Now, that means the piston over here is smaller than the piston at B. Okay, piston A is smaller than piston B. So now what they have done over here is they have placed a weight. So when we place a weight at a piston, what happens? That piston will move downward because of the weight, and the weight gives a force. That force is F1. With this force F1, which is given by this weight, the piston moves downward. But when the piston moves downward, there is liquid over here, which gives pressure P1. Now the same P1 gets transmitted over here. And what I have told you is, pressure at every point is equal. It means that P1 and P2 is equal. Remember that, you read that afterwards. P1 and P2 is equal. So the pressure gets transmitted from this part, which the force of this weight has been applied, and it gets transmitted over here. And when the liquid moves downwards, the liquid over here will move upward. So this piston will move upward. You can see an arrow over here, that is F2. The force is in upward direction. That is due to the pressure at this point. So the F1, which is the force at piston A, will be giving you the force F2 at piston B. So your F1 is due to the small area. F2 is a force on a bigger area. So what this states is F1, which is a smaller force, will generate a larger force. So hydraulic machine is kind of a force multiplier. The force which is small F1 will generate a larger force, that is F2. So in this diagram, this is the same diagram, but a small calculation is there. So you can copy it from here also, and the same calculation is given in the book also. So in this diagram, what I have told you is a weight is kept on a piston A, due to which a pressure is there, and that pressure is transmitted from this point, that is piston A, to piston B, and the force which is applied on that piston is F2. That is an upward force, this is an downward force. So what I told you, force P1 and P2 is same. P1 is opposed to P2, first equation. Now, what is force? From the equation of force, we know that force is equals to, pressure is equals to force per area. Force applied in a certain area, that is F1 divided by A1. That is pressure P1. P1 is force F1 divided by area A1. Similarly, P2 is for pressure over here, that is F2 divided by A2. Now, I have told you P1 is equals to P2, that is why FA1 is equals to FA2, which is written over here. F1 divided by A1 is equals to F2 divided by A2. Now, cross multiplication, simply cross multiplying these two things. F2 goes in the denominator, A1 goes in the numerator. Now, since what we can see is, since area A2 is greater than area A1, from this diagram, this area A2 is greater than area A1. So, what happens is, the force generated by that area, F2 will be larger than F1. Remember that, larger the area, larger will be the force. So, larger area A2 gives a larger force, that is F2. So, from here what we can understand and what we can prove is hydraulic machine, which is principle. This is a principle of hydraulic machine. Hydraulic machine acts as a force multiplier. This is a very important term, force multiplier. Remember this might be asked in exams again and again. That is, what is hydraulic machine used for? Hydraulic machine is used to multiply force. That will be the answer. So from here, this is a proof of that. That if area is larger, force will be multiplied, and that is the principle of hydraulic machine. Now in your book, there are few topics, but those topics are not there in the syllabus. We just can go through that. That is hydraulic press, hydraulic jack, and hydraulic brakes. We don't have to go in depth of that, just the basic concept of hydraulic machine. It is using a force, we can multiply force at certain point. Okay, so that is the principle of hydraulic machine, and if you have understood that, in the next class we will move on to another topic, that is atmospheric pressure and its measurement. So that is important and that is in the syllabus. So in the next class we will be discussing about atmospheric pressure and its measurement. I hope till here it is clear. If you have any doubts, you are free to ask. Please ask if you have any doubt. Okay? Thank you for today. Stay safe.